Hello students, how are you? I am Assistant Professor Karan Kumar Das, come back again, and today our topic of our lesson is the acetic acid. Okay, so acetic acid is basically what? First, we are knowing the chemical formula of the acetic acid. Hope you know everyone because we have studied it since class 7 or class 8. The chemical formula of the acetic acid is the CH3COOH. Okay, and it is also known by us in the name of the ethanoic acid. And acetic acid basically one major constituent of vinegar. 4 to 6% of acetic acid contains by vinegar. Okay. So, how we will prepare acetic acid? There are the several methods of the preparation for the acetic acid, but for the large scale preparation in the industry, they will use from the aldehyde. From the acetaldehyde, they will prepare acetic acid. How? By the air oxidation method of the acetaldehyde in the presence of the manganese acetate at the temperature of the 50 to 70 degrees Celsius. In the temperature of the 50 to 70 degrees Celsius, in presence of the manganese acid catalyst, by the air oxidation of the acetaldehyde, in the industry, acetic acid are produced. What is the chemical reaction? See here, it is the chemical reaction acetaldehyde by the air oxidation in the presence of the manganese acetate as the catalyst on the 50 to 70 degrees Celsius temperature, it is converted to the acetic acid. And one more thing, this acetaldehyde which are used as the raw materials for the preparation of the acetic acid that has been prepared from the hydrolysis of the acetylene in the presence of the sulfuric acid and also the mercurous sulfate. Okay, in the presence of the mercurous sulfate and sulfuric acid, it is converted to the acetaldehyde. Now, the question is what is the method? See, if you want to know with proper diagram the method, you can consult the book of the Organic Chemistry Val and Val, page number 440. You have got it on that book, total the procedure with proper diagram. I am describing you very shortly. Actually, what will happen? The total procedure is happening is a stainless steel container. Okay, the total reaction between the acetaldehyde and oxygen in the presence of the manganese acetate, that total procedure is happening in a stainless steel container, and there actually a flow of the acetaldehyde is containing in the stainless steel container and some manganese acetate is also added with this flow of the acetaldehyde. And the temperature 50 to 70 degrees Celsius is maintaining by some steam coil, and at the ending 95% crude acetic acid is found, and the acetic acid is furtherly purified by the distillation method. This is the overall industrial preparation procedure of the acetic acid. We have studied well this point because it is the one important question for your examination, the industrial preparation procedure of the acetic acid. There are some another process also, like the air oxidation method of the butane. From where we have got the butane? We have got the butane from the petroleum. So, if butane is oxidized, it is converted to the acetic acid, and here cobalt acetate is act as a catalyst. In the previous method, that is the industrial method preparation of the acetic acid, there manganese acetate was used, here cobalt acetate was used for the case air oxidation of the butane. Okay, see here, butane is converted to the acetic acid by the oxidation. Butane is converted to the acetic acid by the oxidation, and cobalt acetate is used as the catalyst. Okay, this is the second method. And third one, the quick vinegar process. Actually, it is used basically for the food industry. For the food industry, for the large scale of the preparation of the vinegar, this method is used. What is happened in this method? Here actually, this vinegar, previously I have also described, vinegar is nothing but the 4 to 6% of the acetic acid. This vinegar, for the large scale preparation of the quick vinegar process, here actually obtained from the fermented liquids which contains 12 to 15% alcohol. The fermented liquid which contains 12 to 15% ethanol, if we oxidize it in the presence of the one bacteria known as the Bacterium aceti, that produces the acetic acid. Okay, that means if the aqueous solutions of ethanol which contains 12 to 15% of the ethanol, if we oxidize it in the presence of Bacterium aceti, then it is converted to acetic acid. See, actually this reactions is happening in the two steps. In the first step, the ethanol reacts with the oxygen in the presence of the Bacterium aceti and it is converted to aldehyde. Okay, that means acetaldehyde. If here I have given the example with the ethanol, ethanol reacts in the first step, that means alcohol, ethyl alcohol reacts with the oxygen in presence of the Bacterium aceti, bacteria, and it is converted to the acetaldehyde. In the second step, acetaldehyde again reacts with the oxygen in the presence of the Bacterium aceti and it is converted to the acetic acid. Okay, if your question will come, how the food industry prepared the acetic acid, then your question answer will be this procedure. Okay, but if your question will come, what is the industrial preparation procedure of the acetic acid, then your question answer will be the first point, the air oxidation of the acetaldehyde in presence of the manganese acetate. Okay, so two questions are the different. Don't be confused. Clear? Don't be confused. For the preparation of the vinegar in the food industry, the Bacterium aceti will be your answer. In the presence of the Bacterium aceti, the reactions with the aqueous ethanol with oxygen, this will be your answer. And for the industrial preparation, that will be your answer, the air oxidations of the acetaldehyde. Don't be get confused. See here, it is the two-step procedure reactions. In the first step, ethanol reacts with the oxygen in presence of the Bacterium aceti, okay, and it is converted to aldehyde. And in the second step, acetaldehyde reacts with oxygen, again it is get oxidized in the presence of the Bacterium aceti and it is converted to the acetic acid. Clear? Now, and one more thing, this procedure, quick vinegar procedure, if you want to know, it is also described in the organic chemistry of the Val and Val, page number 441. You can study from there the detailed procedure. Okay, now I want to describe what are the physical properties of the acetic acid. What are the basic physical properties of the acetic acid? First point, it is one, colorless. Number two, it is corrosive liquid. Number three, it is the vinegar odor. And number four, it is containing the sour taste. Okay, its melting point is approx 16.6 degrees Celsius and boiling point is approx 118 degrees Celsius. And its vapors are the suffocating and cause the damage of the lungs. The vapors of the acetic acid causing the damage of the lungs. And here one question also coming, what is the glacial acetic acid? Actually, pure acetic acid, which is the most purest form of the acetic acid, that is known as the glacial acetic acid, because when it gets cooled it forms one ice-like structure. Due to that reason, the pure acetic acid known as the glacial acetic acid, and it is dissolved in water as well as in the ethanol or any organic solvent. And what are the main use of the acetic acid? It is used basically production of the white vinegar. Already I have told it. It is the main use of the acetic acid, and as well as to produce the cellulose acetate or polyvinyl acetate. That's all the acetic acid. And if you want, you can take the screenshot of today's lesson from this note. Thank you. This is the industrial preparation of the acetic acid for the industry purpose. And now the second one, it is the air oxidation of the butane and along with the total quick vinegar process, okay, with reaction. And finally, it is the properties along with the uses of the acetic acid. Here the important question is the what is glacial acetic acid. Thank you. That's all for today's lesson. If you feel any doubt, you can feel free to contact with me on my WhatsApp number 9804915527. If you feel free to contact me there. Thank you. Take care of your health. Stay safe. Stay home. Sincere on your study. Have a good day.